This is SpaceTime Series 29, Episode 27, for broadcast on the 4th of March 2026. Coming up on SpaceTime, is a supernova about to explode in our skies? NASA's new cinema mission to study auroral activity. And NASA moves Artemis 2 back into the hangar. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers are breaking out the popcorn and Slurpees as one of the largest known stars in the universe is starting to show the first signs of getting ready to explode as a supernova. Supernovae mark the cataclysmic death of stars. They result in explosions so bright it can easily outshine an entire galaxy. In this case, the star being watched is WOHG 64. It was first discovered back in the 1970s, 163,000 light-years away in the Large Magellanic Cloud, a satellite galaxy orbiting around our own galaxy, the Milky Way. WOHG 64 is one of the brightest and most massive stars known, with a luminosity around 282,000 times that of the Sun and roughly 20 times the Sun's mass. Right now, the star is a red supergiant, the end result of a former main-sequence blue star that ceased fusing hydrogen into helium in its core and has begun fusing helium into progressively heavier and heavier elements. Eventually, the star will try to fuse iron, which it can't no matter how big it is. And so the great balancing act between gravity crushing the star's mass inwards and energy from nuclear fusion pushing outwards suddenly ceases, and gravity wins, causing the entire mass of the star to quickly collapse down into the stellar core, resulting in a supernova explosion. Back in 2014, WOHG 64 was seen to undergo a dramatic transformation, turning from a red supergiant into a rare yellow hypergiant. The findings, reported in the journal Nature Astronomy, suggest that this may well be a sign of an impending supernova explosion. Now, this star is not only extremely luminous and massive compared to the Sun, it's also one of the physically biggest ever discovered, some 1,500 times the size of the Sun. The star is right now shedding off its outer layers, shrinking as it heats up and moving closer to the end of its life. In 2024, WOHG 64 was the first star beyond our galaxy ever photographed in detail using the interferometer on the European Southern Observatory's Very Large Telescope, the VLT, in Chile. That image showed a clear dusty cocoon around the giant star, confirming that it was losing mass as it aged. WOHG 64 has an estimated age of a bit less than 5 million years. Now that's far younger than the 4.6 billion year age of our Sun. You see, big stars like this one are often referred to as the James Deans of the universe. That's because they live fast and die young, burning through their nuclear fuel supplies far quicker than their less massive counterparts. Now, not all supergiants become hypergiants. It's hypothesized that this only happens when really extremely massive stars burn through their core hydrogen unusually quickly. During this transition, the stars start to shed off their outer layers while their cores begin to shrink inwards. Once a star becomes a hyperstar, it's destined for a quick supernova death. The changes seen in WOHG 64 back in 2014 are thought to have been caused by a large part of the original supergiant's surface being ejected into space, away from the stellar core. Now, this may have been caused by some sort of gravitational perturbation following a close encounter with a companion star. Another idea is that the change in colour and size is caused by a pre-supernova wind caused by strong internal pulsations as the fuel in the core is quickly spent. As for when the blast occurs, well, it could be today, maybe tomorrow, or in a few thousand years from now. We'll all just have to wait and see. This is SpaceTime. Still to come, NASA's new cinema mission to study auroral activity, and the Artemis 2 mission to bring humans back to the Moon suffers another setback as the massive rocket is moved back into the hangar. All that and more still to come on SpaceTime. NASA's announced a new mission to explore Earth's spectacular auroras and how the planet's mysterious magnetotail affects them. The cross-scale investigation of Earth's magnetotail and aurora, or SINEMA for short, will launch in 2030. The Earth's northern and southern auroral lights, the aurora borealis and aurora australis, are generated by charged particles from the sun slamming into the Earth's upper atmosphere and interacting with the atoms and molecules located there. That causes the kaleidoscope of coloured curtains observed, with the different colours generated by different gases being hit in the atmosphere. But Earth's mysterious magnetotail also plays a part in the celestial sky show. Much of what we see as auroras near the northern and southern magnetic poles begins as plasma currents in Earth's magnetotail, the part of the planet's magnetosphere that stretches behind the Earth, sort of like a windsock generated by the solar wind. Thoroughly understanding how processes that occur hundreds of thousands of kilometres away can create specific auroral formations in the atmosphere will require measurements of particles and electric currents flowing in from the magnetotail combined with orbital auroral imaging. And that's where the SINEMA spacecraft come in. SINEMA principal investigator Robin Millan from Dartmouth University says explosive magnetospheric phenomena can have major impacts on our technological systems. She says science fundamentally doesn't understand when the magnetotail's going to release magnetic energy, or how much impact that might have. SINEMA will comprise a constellation of 9 small satellites, the first to focus on remote sensing of the magnetotail. Millan believes that the measurements and images that SINEMA gathers will lead to a better understanding of the conditions that initiate substorms and how they create specific auroral forms. When energetic particles from the solar wind strike the sunward-facing bow shock of the magnetosphere, they wind up being captured by the magnetotail, where some are cycled back towards the Earth, creating a constant plasma convection pattern known as a Dungy cycle. Energy accumulated by this cycle is frequently disrupted by explosive magnetic events known as substorms, which cause plasma flows to surge towards Earth, generating intense auroral activity. Science's conception of substorms began back in the 1950s and 60s, driven largely by measurements of ground-based all-sky imaging of auroral activity and particle measurements taken by satellites. All-sky cameras use very wide-angle lenses, allowing them to capture almost 180 degrees of the sky from horizon to horizon. Early models, which took long monochromatic exposures on film, were only sensitive enough to observe broad trends. SINEMA's 9 spacecraft will use advanced digital cameras capable of capturing dim auroral activity from a probe moving at some 7 kilometres per second. They'll take multiple short-exposure images in sequence, slightly shifting each shot to compensate for the spacecraft's motion, and then combining the images into a single picture. The SINEMA team will focus on different auroral forms, and they'll attempt to determine how they're linked to the structure of the magnetotail. Then there's the issue of poleward boundary intensification. That's a sudden brightening of the poleward edge of an aurora. It's thought to be the first sign of a magnetic reconnection event within the magnetotail itself. These are events which occur when magnetic field lines in the magnetosphere encounter oppositely magnetized plasma in the solar wind. Another auroral form SINEMA will study is what's known as auroral streamers. These are long auroral arcs oriented north to south, as opposed to the more common east to west formation. Finally, there are things called auroral beads, which, as their name suggests, look like beads on a necklace. Now, all these different auroral forms, which can be seen with the naked eye, may be signatures of intense plasma flows in the magnetotail. But to find out for sure, SINEMA will employ a remote sensing technique to monitor the magnetic structure of the distant reaches of the magnetotail. SINEMA's magnetometers will measure electric currents flowing between the magnetosphere and the ionosphere, and at the same time, particle detectors will measure electrons and ions flowing in from the magnetotail. The angle of these particle flows compared to the orientation of Earth's magnetic field will reveal the structure of the magnetotail along the same magnetic field line, which will then allow the SINEMA team to study how the magnetotail changes before explosive events like substorms. Now, it may well turn out that localized magnetic fields in the ionosphere play a much larger role in shaping auroral forms than the magnetospheric plasma flows, but there's still a lot of disagreement among physicists over this point. SINEMA's proximity to the ionospheric magnetospheric plasma system will allow for detailed study of this region and should clarify which magnetic structures are most important to auroral formation. Persons standing at Earth's equator at midnight might be directly beneath an intense plasma flow, but the associated aurora wouldn't emerge at the equator. The energy would follow a magnetic field line to the northern or southern pole, where the magnetic field lines are all bottlenecked into a zone called the auroral oval. Each cinema spacecraft will pass through the night-side auroral oval about 30 times a day. In the first phase of the science mission, the 9 spacecraft will follow one another in line. This will allow observation of the evolution of plasma flows and aurorae over a 45-minute period. This series of images will then serve as a short video with associated magnetic measurements for each frame. In the next phase of the mission, the spacecraft will reform into a 3x3 grid constellation, which will allow for broader spatial measurements and images. This report from NASA TV and the Johns Hopkins Applied Physics Laboratory.
Cinema is a small explorer mission, and it's 9 small satellites. The goal of Cinema is to study the dynamics of Earth's magnetosphere. So we're looking at the night side magnetosphere where the magnetic field gets stretched out. And the idea is to study what are called auroral substorms when we see big auroral displays.
An aurora is essentially a glow of light that you see in the sky, and it's created when charged particles, electrons or ions, stream in from out in space and impact Earth's upper atmosphere. When they impact it, they heat it up and cause it to glow. The whole magnetosphere is full of plasma, so charged particles, and the energy is kind of moving through the magnetosphere. When the energy is moving through the system, it can either move kind of in a steady way, or it can move explosively. And also, that's when we get the most spectacular auroral displays. Cinema is designed to study 3 different kinds of aurora. The first one is called a poleward boundary intensification, and we think that this is kind of the first step to that large-scale energy transfer in the magnetotail. The second type is called an auroral streamer. And these are interesting because they're aligned north-south rather than east-west. And these are thought to be connected to intense plasma flows out in the magnetotail. And finally, auroral beads. And those too often happen right before sort of the most explosive energy releases. Cinema is the first mission that is combining auroral imagery, magnetic field measurements, and particle detections on a constellation of satellites in low Earth orbit.
The particle detector and the magnetometer is gonna measure the dynamic of the same magnetic field line that is stretched all the way to the magnetotail. And at the same time, our camera is gonna take a picture on those aurora.
And it's going to be really amazing what we learn about our magnetosphere. But the data set that we're generating is going to enable the whole heliophysics community to do lots of other kinds of science.
And in that report from NASA TV and the Johns Hopkins Applied Physics Laboratory, we heard from Cinema Mission Principal Investigator Robin Milan, Cinema Mission Auroral Imaging Instrument team member Claire Gasco, and Cinema Mission Auroral Imaging Instrument Operator Haiyang Wu. This is SpaceTime. Still to come, well, it's scrubbed for now as NASA moves the giant Artemis 2 moon rocket back into the hangar. And later in the science report, a new study shows that climate change is even affecting tropical plants. All that and more still to come on SpaceTime. NASA's been forced to roll its giant 98-metre-tall Artemis 2 moon rocket back into the vehicle assembly building at the Kennedy Space Center in Florida. NASA had targeted March the 6th as the launch date for the Artemis 2 mission, which will return humans to lunar orbit for the first time in more than half a century. But it wasn't to be. The rollback follows the discovery of a problem with the helium system in the Space Launch System SLS rocket's upper stage. Helium is an inert gas. It's used to maintain pressure in the liquid hydrogen and liquid oxygen propulsion systems as the fuel is used up. This launch had already been delayed by problems with the liquid hydrogen fuel system, which was allowing the cryogenically cooled liquid to leak out. There are also minor issues with the pressurization valve that needed replacing on the Orion spacecraft's crew hatch, as well as both communications and camera dropouts. And while all of these issues have now been sorted out following a second successful wet launch dress rehearsal on the pad, the new helium problems have come out of the blue. The system had worked nominally during both wet dress rehearsals. But during a routine repressurization operation, mission managers suddenly discovered they couldn't get helium flow through the vehicle. Interestingly, a similar issue developed during the Artemis 1 mission. Now, the problem could be a filter in the ground-to-vehicle umbilical, or it could be a quick disconnect interface, or an internal check valve on the rocket itself. That's what happened to Artemis 1. Problem is, all these components are inaccessible on the launch pad, meaning repairs can only be done once the rocket's back inside the vehicle assembly building, hence the rollback. While the Artemis 1 mission was an unmanned test flight around the moon and back, Artemis 2 will carry a crew of 4. After they launch, they'll spend a day in Earth orbit testing systems aboard the Orion spacecraft, including life support, avionics, maneuverability and docking ability, as well as crew radiation protection. If all that goes well, they'll ignite the Orion's main engine and undertake a translunar injection burn which will send them on a 4-day journey to the moon. A number of experiments and the deployment of 5 satellites will take place during the flight. Orion will then travel around the moon, swinging out to between 6,500 and 9,500 kilometres beyond the lunar far side, which will be the furthest humans have ever travelled from Earth. They'll have several hours to study and image the lunar far side before undertaking another engine burn to bring them back home again. All in all, the mission will last 10 days, with splashdown taking place in the North Pacific Ocean off the California coast. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that climate change is even affecting tropical plants, which weren't expected to be influenced because tropical temperatures don't fluctuate that much over the course of a year despite global warming conditions. The findings, reported in the journal PLOS One, examined data from museum collections comprising 33 species from across more than 2 centuries. Scientists found some tropical plants are now flowering either earlier or later than what they used to, in some cases by a matter of weeks or even months. The authors say this shift is similar to changes previously found in plants that live in cooler climates. While the ecological impacts are not yet fully understood, scientists warn there's a growing risk of mismatches between tropical plants and the animals that spread their pollen or eat their fruit. Fossils of an ancient marine amphibian that once stalked the coasts of Western Australia 252 million years ago have been rediscovered after having gone missing from museum collections for over half a century. The fossils were originally discovered back in the 1960s and 70s and identified as a species of marine amphibian called Euthrobacterus nuncabinensis, a crocodile-like relative of modern salamanders and frogs that grew to over 2 meters in length and lived at the beginning of the age of the dinosaurs. The fossils were found mislabeled in a museum collection in California. Now, a report in the journal Vertebrate Paleontology says a reanalysis of the fossils shows they actually belong to 2 different marine amphibians, Euthrobacterus and Aphamerama. The authors say Euthrobacterus has a roughly 40-centimetre head and was likely a broad-headed top predator, while Aphamerama was similar in size but with a long, thin snout designed for catching small fish. A new study claims that people really do consider deeper voices more attractive. The findings, reported in the Journal of the Royal Society Open Science, show both women and gay men find deeper, more masculine voices to be hot. The authors say most studies into vocal preferences have been done using straight people only, finding that men prefer more feminine voices while women prefer more masculine ones. So in 2 experiments testing how different these preferences were for gay people, researchers recruited 2 sets of 180 adults with equal numbers of gay women, gay men, straight women and straight men. They asked the first group to rate the attractiveness of a series of voice recordings digitally altered to sound more masculine or feminine, while the second group rated recordings of people who altered their own voices to sound more masculine or feminine. The results show that gay men and gay women, as well as straight women, were all more likely to prefer masculine voices, while straight men preferred feminine ones. Samsung's new S26 Ultra smartphone's just been released, and it's loaded with a range of upgraded features. But its new privacy display, which can be turned off and on depending on your preferences, is what's getting all the attention. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
The world has been waiting for Samsung to launch its next generation flagship models, the Galaxy S26 range. and they're saying that it's the most intuitive Galaxy AI phone yet. Now, clearly, you would expect things like improved camera system and intuitive AI experiences. I mean, one of the things they've done, besides continue their efforts with Google's Gemini, is to integrate Perplexity. Perplexity is one of the AI services that started off by showing you the sources and really making an effort to show you where it got its information from. And now all of the AI companies do that. They have had to. I mean, they needed to match what Perplexity was doing. The chip inside is a Snapdragon 8 Elite Gen 5. And this is a special version for Galaxy. This has been the case for the past few years, where there's an extra special version made for Samsung's top-tier devices. Now, there's also a redesigned vapor chamber inside. This is with thermal interface material positioned along the sides of the processors. This allows heat to spread more efficiently across a larger surface area. And you want to see improvements in this heat dissipation, because heat is one of the things that causes the CPU and I guess the GPU and the NPU, the neural processing unit, to throttle, when things get too hot. Now, we do have Qi 2 charging, but unfortunately there's no magnetic ring as you've got with the Pixel series, where they call their version of Apple's MagSafe, they call it Pixel Snap on the Pixel range. Samsung is selling a case that has the rings, and you can buy any number of cases that have that ring, but it's just a shame they didn't build it in. But then we have the camera system. They've got enhanced nightography video. Samsung has always been very good, as has Google Pixel, at recording a video at night. This is improved. There's the super steady capabilities, which effectively tries to do away with you needing to have a gimbal. It also supports the APV professional grade video codec, so they're trying to get their device used by more cinematographers and people who want to make more serious videos, more than just the happy snaps that people take. There's a creative studio that's built in. This is where you can start from a sketch or a photo or a prompt, and then you can turn those ideas into a polished result. So it's like having the ability to use some of the text to photo capabilities of various AI systems, but it's just built in. There's also a thing called Now Nudge. Now, this is a copy of what Google's Pixel did with the Pixel 10, where you get these timely and relevant suggestions that just pop up, so you can stay in the flow, they say, without being distracted. So if you've got a friend that's asking for photos from a recent trip inside of Messages, then the Galaxy S26 can automatically suggest recent photos from the gallery. So you don't have to switch between apps or search through all sorts of different photos to find that. It's trying to be helpful and give you the information you need when you need it. There's also a better version of Now Brief, which was part of the S25 range, where you could get a briefing of things you had to do during the day, meetings that were coming up, traffic conditions, other things that I thought you needed to know. You've still got the Circle to Search with Google. There's an upgraded Bixby, which is Samsung's own intelligent assistant, and they're trying to make this easier to interact with Galaxy devices by voice, because they don't want to just hand it all off to Gemini or to Perplexity. I mean, they want to have their own AI system too, and that's how you can also control the various Samsung devices that are part of the whole Samsung ecosystem, the fridges and washing machines and various other things that they have. And now, probably the big feature that everyone's talking about is this privacy display. So at the moment, if you want to have a screen protector that has a privacy shield in it, you've got to buy that. It's separate. You put it on there, and then if someone's picking over your shoulder or looking from the side, they just see effectively a dark image. They can't really see what's going on, which is why it's called a privacy display. But here, this has been built in directly into the device, and you can turn it on, you can turn it off. So it's hardware and software that are working together to protect privacy without compromising the viewing experience. And it effectively controls how pixels are dispersing light. And unlike the regular stick-on privacy films, you can actually switch it off. I wish I could do that on my iPhone, because I'm showing something to somebody and I have to say to them, look, you have to look at it in a certain way because I've got the privacy shield on. And if you're looking at too far from the side, you'll just see this black image. So I wish I could switch it on and off. So it's cool to have that feature. Now, you also have things like call screening to identify unknown callers and summarize the intent of the call before you have to actually answer the call, and privacy alerts to show you in real time when apps are using privileges to unnecessarily attempt to access sensitive data. I mean, we see that on iPhones where you have the little, I think it's the orange dot showing you when the camera is on. I think it's a green dot when the microphone is on. Then you've got this private album, which is supposed to have post-quantum cryptography protection, so that when quantum computers become standard, the encryption that's on your phone, even though quantum is supposed to break it, this is somehow supposed to stop quantum technology breaking it. I mean, exactly how they're doing that, I don't know, but they talk about it. So look, there's lots of different things. The actual devices will be on sale from March 11 in Australia.
That's Alex Zaharov-Reutt from TechAdvice.life, and this is Space Time. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.